Unit 1, Lesson 2, Factoring Part 1. So we're going to be reviewing a couple of the factoring methods that you would have learned in grade 10 math, and I'd ask that you have to be super honest with yourself. If you are not comfortable with factoring or you didn't feel like you understood it very well last year, you need to put in the effort to get extra help, because factoring is very important for 11U and you need to be able to do it pretty quickly. Okay? So let's review common factoring first. Alright, so common factoring is when there is something common in each of the terms in the polynomial. Okay, and once you've figured out what that common thing is, factor it out of each term and put it outside of the bracket. And then you put what's left over inside of the bracket. Let's get right into an example. 14x squared minus 20x plus 36x cubed. So we need to figure out what is common between each of those three terms. And I like to divide it up. So first ask yourself, what is common between each of the numbers? Or what can each of those numbers be divided by? Okay, so I can see that they can each be divided by 2. Okay, and that's the highest number that they can be divided by. So 2 is part of my greatest common factor. Now let's look at the variables. One's got an x squared, one's got an x, and one's got an x cubed. The thing that is common between each of those three terms is just 1x. They all have at least 1x. So there is the second part of my greatest common factor. Okay, now we need to write out what is left after we take out or divide each term by 2x. Okay, so what's 14x squared divided by 2x? And if you need to work on the side, you can just do this. Okay, 14 divided by 2 is 7. X squared divided by x to the 1 is x, because you subtract the exponent. Okay, so that's the math behind it. You're taking the original term and dividing it by the greatest common factor. Some of you will be able to just do it in your head without doing that math off to the side, and that's fine. Okay, negative 20x divided by the greatest common factor by the two numbers, so negative 20 divided by 2 is negative 10. And x divided by x cancels out, so we're just left with negative 10. And finally, 36x cubed divided by 2x is equal to, so 36 divided by 2 is 18. X cubed divided by x to the power of 1 is x squared. Okay, so that is how you would common factor that original polynomial. Okay, I'm going to do the next one and I'm going to do it a little bit quicker. I'm not going to show that math off to the side, but feel free to do that if you need to. Okay, so let's figure out what the greatest common factor is. So what is common between all the numbers? 15, 24, and 6. You're going to realize they can each be divided by 3. Okay, now we've got a's and b's as our variables. So let's look at the a's first. Is there an a in every single term? And how many can we factor out of each term? Okay, first term's got 1a. Second term has 2 a's. Third term only has 1. So we can only take a maximum of 1a from each one. Now let's look at the b's. We've got a b squared, a b cubed, and just a b. So again, we can only take a maximum of 1b from each. So there's our greatest common factor. Now let's divide each of the terms by that 3ab, or by that greatest common factor, to see what's left for inside of the brackets. Okay, so I just took each term and divided it by 3ab. Okay, so that's common factoring. Scan the equation, figure out what is your greatest common factor, and then divide each term by that greatest common factor. Okay, method 2 is called decomposition or magic number method. Okay, you might have heard of it as both, but this is where you're factoring quadratic expressions in this format, and the way you approach these types of questions, you want to look for two numbers that multiply together to get the product of a and c, and those same two numbers added together get your b value. And there is a shortcut. So if a is equal to 1, so if there's no numerical coefficient in front of that x squared, then your magic numbers become your factors. Okay, if you do have a number in front, if a is not 1, there's a little bit more work that needs to be done. And if you remember it from grade 10, great. If not, I'll show you. Okay, so let's remind you of this factoring method through some examples. I need two numbers that when you multiply them together, you get 60. And those same two numbers, when you add them together, you get 17. What are the two numbers? Okay, so you're going to realize it's 5 and 12, because 5 times 12 is 60, and 5 plus 12 is 17. Now, because this is an example where a is 1, we can take that shortcut. Okay, our two magic numbers automatically become the factors. So we just set up our brackets. One number goes in one bracket and the second number goes in the other. So we have x plus 5 and x plus 12. And then we're done, it's factored. Okay, you can only take that shortcut when a is 1. When a is not 1, there's a little bit more work that has to be done. Alright, so the first thing I want to show you guys is that sometimes you're going to have a situation where you can actually common factor the expression first, and then it makes figuring out what the magic numbers are a little bit easier. So, rule of thumb, always scan your equation first before you start factoring. See if you can common factor something out. Okay, because you'll notice each of these numbers can be divided by 3. So I'm going to common factor out of 3, and then I'm left with x squared minus 3x minus 40. Okay? Now let's factor what's inside of the brackets. So I'm going to use the magic number method, or decomposition. So I need two numbers that multiply together to get negative 40, and those same two numbers, when added together, have to get to negative 3. What are the two numbers? Hopefully you can figure it out as negative 8 and 5. Now because a is equal to 1, those magic numbers become your factors. Okay, and then we're finished. Okay, so I'm now going to show you an example where a is not 1. Okay, and how do you handle it? So right away, let's look at part C. We can't common factor it. Okay, so let's use decomposition. Let's use our magic numbers method. I need two numbers that when multiplied together, they have to add up to the product of a and c. So 5 times negative 14, which is negative 70. Those same two numbers have to add up to our b value, which is negative 3. Okay, what are the two numbers? The two numbers are negative 10 and 7. Because a is not 3, we cannot just jump down to our line with the factors in it and say our first factor is negative 10 and our second factor is 7. Okay, that's only when a is equal to 1. So what you do here, if you remember, is you replace your b term with your magic numbers. So I'll show you what I mean. So instead of writing minus 3x, I'm going to write negative 10x and positive 7x. So I simply replaced the b term with my two magic numbers. Hence why it's called decomposition. Okay, and the reason why we can do that is because if you were to actually simplify this, right, negative 10x plus 7x, you just get back up to negative 3x. So I'm not changing the question. It's just how you would approach this type of factoring method. So now what you do, now that you've plugged in your magic numbers as that middle term, you're going to common factor the first two terms and common factor the second two terms. Let's common factor 5x squared minus 10x. So we can factor out 5x, that's common between both. And then we have x minus 2 left over. Let's common factor the 7x minus 14. We can factor out a positive 7. And then we get x minus 2. Now, you can see that both are multiplied by x minus 2. So we can simplify this a little bit here. So both the 5x and the plus 7 are being multiplied by x minus 2. So we can rewrite it like this. Because if you were to do FOIL, naturally the 5x would be multiplied by the x minus 2, and the 7 would be multiplied by the x minus 2. So these two lines are the same. Just this one's written as the factored form, which is what we want to get to. Okay, so think of it basically as your two numbers out in front, put them together and form your first set of brackets. And then these two guys are always going to be the same, so that becomes your second set of brackets. Let's try that one more time. So part D, okay, I'm just going to quickly write this in decreasing order by degree. Okay, so I'm going to put my 6x squared first, then my negative 19x, then my 10, just so I can identify my a, b, and c value a little bit easier. Let's look for common factoring. There's nothing that we can factor out, so let's go to our decomposition method or magic numbers method. We need two numbers that when you multiply them together, you get 60, right? Multiply your a and your c together. And those same two numbers have to add together to get your b value, which is negative 19. What are the two numbers? Okay, negative 15 and negative 4. Work. Okay, so once we've identified our magic numbers, the next step is replace the b term with your magic numbers. So instead of writing negative 19x, I'm going to write negative 15x minus 4x. Okay, next step is common factor the first two terms and common factor the second two terms. I can factor out a 3x. Okay, and over here, I can factor out a negative 2. Okay, and if you didn't factor out a negative 2 and you factored out a positive 2 instead, what would happen is your second set of brackets would not be the same as your first set, and that would be kind of your red flag, and you'd realize, oh, I guess I should factor out a negative 2 instead of just a positive 2. So you want those brackets to turn out the exact same, because now we can come up with our factors, right? I said take your coefficients from both. That becomes one set of brackets, and then your identical brackets, you can just write it once. And that's your second set of brackets. Okay, and then this is factored. Okay, the third factoring method that you would have learned in grade 10 is difference of squares. Difference of squares is a very quick factoring method, but sometimes is overlooked. So basically, you want to look for a binomial, so it has two terms. Each of those two terms are perfect squares, meaning they have a square root. You can take the square root of them, and they're separated by a subtraction sign, hence the word difference. Difference means subtraction. If both those things are in place, you can use this factoring method. So in this situation, yes, both x squared and 4, you can take the square root of them, and they're separated by a subtraction sign. So we can use difference of squares here. Now the way you apply this method is, Once you've identified that they are in fact a difference of squares, to factor them, all you do is you set up your two sets of brackets, you take the square root of the first term, so the square root of x squared is x, and you write it down first. Then you take the square root of the second term and write it down second, so the square root of 4 is 2. And then one bracket gets a addition sign, and one bracket gets a subtraction sign. And then you're done. Now it's factored. Okay, part B, 4x squared minus 25y squared. Let's check to see if this is a difference of squares. Okay, and yes it is, because you can take the square root of 4x squared, you can take the square root of 25y squared, and it's separated by subtraction. So we can use the difference of squares method on this question to factor it. So set up your brackets, take the square root of the first term, so that square root of 4x squared is 2x, and write it down first in both brackets. Then take the square root of your second term, okay, so 5y, and write it second. And then put an addition sign in one of the brackets, subtraction sign in the other. Okay, so difference of squares is really nice. It makes it quick and easy. Let's go ahead and try the third one. Is this a difference of squares? Yes, it is. Both terms, you can take the square root of them, and it's separated by a subtraction sign. Set up your brackets. Okay, what's the square root of 64a to the power of 4? Okay, so what's the square root of 64? It's 8. And then what times itself is a to the power of 4? A squared. Okay, so that's the square root. Okay, so what's the square root of 625b squared? Well, the square root of 625 is 25, which you're welcome to use your calculator to figure out, and then the square root of b squared is just b. And then put a addition sign in one and a subtraction sign in the other. We are done. Okay, the last method that we're going to go over is called factoring perfect square trinomials. The way that you determine if something is a perfect square trinomial is as follows. So first of all, make sure it's a trinomial. Make sure you have 3 terms. Okay, 1, 2, 3. Second of all, make sure the first and third terms are perfect squares. So can you take the square root of the first term and the square root of the third term? And yes, we can, right? Square root of x squared is just x. Square root of y squared is just y. So that's good. Then you have to make sure something happens with the middle term. The middle term has to be 2 times the square root of the first term times the square root of the second term. So 2 times xy is 2xy. If that happens, you can use this factoring method, okay? And I'll show you what the method is in these next few examples. Okay, so part A here, let's see if this is a perfect square trinomial. First and third terms, can you take the square root of them? Yes. Square root of this guy's y, square root of this guy's 4. Last thing you have to check is that middle term equal to 2 times the square root of the first and third term? So is this middle term 2 times y times 4? Yes, it is, because 2 times y times 4 is 8y. Okay, so we can use this method. So the way this method works is once you have identified that it is a perfect square trinomial, all you do to factor it is you take your brackets, you take the square root of the first term, write it down, you take the square root of the second term, write it down, square the whole thing, and then take the sign that's attached to the middle term, stick it in between. Okay, so it's really handy if you can identify that it's a perfect square trinomial. It makes your factoring process really quick. So let's check this one. Is it a perfect square trinomial? So yes, it's a trinomial. It has 3 terms. The square root of the first term is 3x. Square root of the second term is 4. Is that middle term 2 times 3x times 4? Yes, it does. It equals 24x. So this is a perfect square trinomial. Great. Let's factor it now, knowing that it's a perfect square trinomial. So the way you factor it again, set up your brackets, put the square root of the first term first, put the square root of the second term second, take the sign of the middle term, put it in between, and then the entire thing is squared. Okay, last question. And this is a good one because remember I told you in the last few examples, always see if there's something that you can factor out first. Okay, something that is common in between each. And in this case, there is. There's a negative sign in each of the 3 terms that we can definitely factor out. So let's factor out that negative sign first. Now let's see if this is a perfect square trinomial. Okay, so square root of the first term is 2a. Square root of the second term is 7. And let's check to see if that middle term is equal to 2 times the square root of each of those first and third terms. Okay? And you'll see that 2 times 2a times 7 is 28a. Perfect. So this is a perfect square trinomial. Let's go ahead and factor it. So set up our brackets. Don't forget that negative sign that we factored out. Put the square root of the first term first, square root of the second term second. Put the sign of the middle term in between and square it. I hope you feel comfortable factoring. This is a review of grade 10, so please reach out if you are still struggling with your factoring methods, because trust me, you really need to be good at factoring for what is to come in grade 11 university math.